Hi, and welcome to Tremco Live, where we're socially distant but technically connected. We're very excited to be able to get up in front of you each and every Friday to be able to talk to you about design challenges and technologies and just what hot topics that are in the industry today. I am Marcy Tyler, Director of Building Science for Tremco, and I'm joined by my co-host.
And I'm Paul Hugenbaum. I'm the president of Tremco Construction Products Group. Marcy, a tremendous collection of brands, companies, products, systems, and of course, people all over the world.
All over the world. So we're really excited to have this opportunity to be able to represent so many different of our colleagues here each and every Friday, bringing you different types of topics. Now, if you've been tuning in with us regularly, in the month of March, we're talking about versus. So we're comparing different types of technologies. So I think the first week we looked at some liquid applied roofing compared to some conventional installations. We did Puma. And how great that is. We'll continue to visit those technologies. And then last week, we talked all about Securic X4430 and the advantages that that pre-applied air barrier can bring to your project. So this week, I told you last week what it was going to be. Do you remember, Paul?
Well, I did in this case because it's one of my absolute favorites. We were joking right before we got on that I would want it at least monthly as a topic. Yes. Yes. And one of our guests thinks it should be on every week.
Yes, I bet he does. I bet he does. But yes, it is insulated concrete forms. I'm very excited to be able to bring this content to you guys all today. And in our verses, we're putting it under the category of wall construction. This is a great opportunity for us to take on even more of that wall and be responsible for more touch points in your construction project. So as you've known us in the past with air barriers, coatings, roof coatings, waterproofing, sealants, we're excited to be able to get into that wall construction utilizing something like insulated concrete forms.
Yeah, it's Nudura has been an eye-opening since joining the RPM family and then our group. So, like I said, every week should be Nudura week.
We'll see what we can do. Just to make sure you understand what insulated concrete forms are, we want to kind of start there, but we are going to be able to compare it with other types of technologies today. I love this picture here that's featured, Paul, because I think we've done myths as well on our Tremco Live, and this was one of them. I think people think, oh, insulated concrete forms, basement. Not true. It can be used in the basement, but above grade and in many stories, as you can see in that picture.
Yeah, there's really no functional limit. I think there's certainly buildings 25 plus stories, and there's really no reason you can't just keep right on going.
Well, and it can accommodate so many different types of facades too, so I think it really is versatile. When we look at specifically the Nudura technology, you can see that DuraFold, the Duramax, and the Duralock. So Duramax, longest units that you'll find in the industry, that folding technology, which is great from an efficiency getting it to the job site, and of course locking in that Duralock technology, locking it.
Yeah, there are so many, actually over 20 plus years, Nudura's really been the industry leader, and there's just so many little features and benefits throughout the product, and these are of course just a couple of them.
Exactly. And then that reversible system, so it doesn't really matter how you're building it, you can flip them around. So it really is versatile when you're building it. The other thing I always like to just address to make sure we really have the audience understanding what insulated concrete forms are is that they are made up of two panels of that expanded EPS. That thickness of the panels themselves can vary, as well as adding different EPS into that system depending on what R value you're looking for. Then you do add in that concrete into that center, as you can see in that picture. And they are reinforced to give it that structural durability.
Yeah, I'm glad you brought up reinforcement, Marcy, because as you know, we've been working on an exciting project with our Euclid company, part of our group, who's been really a world leader in use of fibers to replace rebar. And we've just done our first commercial pilots, got all our engineering tables done, and I think it's getting full release any day now. But that really eliminates the need for use of rebar, further simplifying installation and giving up nothing in performance. Very exciting.
Yeah, it's very exciting, and I think it should be one of our Tremco Lives. What do you think?
Thank you, Marcy. I was hoping you'd say that.
Yeah, and maybe the whole one will just be on that for sure. Yeah. So much exciting opportunities there, and just the shapes and the ability to accommodate all different types of building designs really does lend to the use of insulated concrete forms in any type of construction. Once again, if you're watching this and you have questions or concerns, we are addressing them in one-on-one meetings in the month of March and April. So you'll get my email at the end of it. Please email me because I'd like to schedule that one-on-one time with you so we can talk through what your design challenges or your concerns are related to insulated concrete forms. I'll bring the subject matter experts to you, you bring me your questions. Speaking of subject matter experts, someone that's taught me a lot about insulated concrete forms is Eric Miller. Eric Miller, welcome to the broadcast.
Hi, Marcy. Hi, Paul. Thanks for having me.
Absolutely. We're so happy to see you and happy to have you part of the broadcast. I think we met in Quebec. Did we meet in Quebec? Or prior
yeah,
to
we had
that?
the distributor
We probably
meeting
met in
last year.
Scottsdale.
Yeah.
Yeah.
It was just when the epidemic was starting.
Yeah, it was my last trip. I went to Quebec to one of their meetings, and and all like distributors were there, and it was a great meeting. Just talking to everybody and getting excited about insulated concrete forms. So.
Yeah, I mean, I've always been kind of a building science geek.
Well,
and
that
so getting to meet our head chief of building science was great.
And I would encourage our audience to follow Eric on LinkedIn. He's quite a poster, if you will. Is that what you call it?
Sure. Influencer,
but always, Eric, very, very thoughtful and content rich, and I appreciate the time you take to do that. I enjoy it on pretty much a daily basis.
Oh, thank you. I appreciate it. I mean, I learned from the best. Our company has the very best insulated concrete form professionals in the industry, and so I was lucky enough to learn from my colleagues so much over the last 6 years now.
Really is a great team, and they really are, really experts in the industry. I've learned so much from them.
Yeah, the leadership, I think, goes back to, Eric, I'm going to say 1996. I don't know if you know the history of the exact year, but it's at least 25 years of leadership from Duramax.
It's very great.
Yeah, it actually goes way back. The story that I always tell is that, really our company has been involved in the insulated concrete form industry almost since its very beginning, because we were making insulated concrete forms for other companies. And then our basically the father of this company created Nudura because they decided that this was going somewhere, and that insulated concrete forms were here to stay. And why don't we just make the most technologically advanced system? And that's what they set out to do, and that's what they accomplished.
So we got a few pictures here and a chart. Tell me what we're looking at here.
So one of the things that really attracted me initially to insulated concrete forms was the thermal performance. I grew up in a house in Massachusetts that was really quite leaky and pretty uncomfortable. And I got obsessed with thermal comfort in buildings because of that experience. And so when I went to go build my own house in Park City in the mid 90s, I gravitated towards systems that were going to be airtight. And so the thermal performance of insulated concrete forms is certainly remarkable. There are other benefits that we're really going to talk about today, but leading that for me was the thermal performance. If you look at this chart, when you think about what we have a mass wall, so we have thermal mass, which is the concrete core, and that can vary in thickness as you described. And then we have continuous insulation. So we have thermal mass plus continuous insulation. And the thermal performance comparison below is from testing that the Insulated Concrete Form Manufacturers Association undertook. And we spent a lot of time and at a great expense to do testing. What they found was remarkable. And we all knew that these walls performed quite well, but after we tested them, we got to see why. So when you look at the bottom of that, it says time to reach equilibrium. And on the side, it says the tested R value. So really the R value of all of the assemblies that we tested was approximately the same. If you look at what we tested an ICF wall, which is basically a 23.59 R value. We tested a wood frame wall with R20 plus 5 continuous insulation, which is going to be required for probably your zones, climate zones 6 and 7 and 8. A wood frame with R24, that's basically 2x6 with R24 stuffed into it, and then a steel frame. And the steel frame is going to test worse because it's got so much thermal bridging in it, but that had continuous insulation on it. And then another wood frame wall at R20. Those walls performed at way below their nominal R value, whereas ICF performed at its R value. So that's remarkable. What's more remarkable is how long it took for the wall to reach equilibrium. In this test, what they do is they drop the temperature dramatically outside the test chamber for days and days and days. And if you look at this, it took hundreds of hours for the wall to equilibrate. And that is why when we use this in a building, no matter what size, whether it's below grade or above grade walls, we reduce the heating and cooling loads for the buildings because of the thermal performance of the wall.
This graph really does show so many of the features and benefits that we talk about related to insulated concrete forms in one graph. It's pretty great.
And it is interesting, as Eric mentioned, everybody talks about R value, but you don't have a lot of discussions going on, as Eric just mentioned. So I think it's just one of the less understood features or less understood critical properties of wall construction.
Absolutely. Absolutely.
And it's kind of one of our Achilles heels, right? When we look at it, we're like, when people ask us, what's the R value? We kind of go, ugh. Because the R value doesn't seem to be so awesome, but the performance is incredible. And that is tested performance now.
Yeah. Well, and I know you've touched on several of these, but I know when we're brainstorming and talking through, we came up with a few bullets, Paul.
Just a few.
Just a few here. And we wanted to be. Go ahead, Eric.
Well, yeah, when you look at the benefits, there's so many benefits of insulated concrete forms. And as you said, we kind of brainstormed and we came up with many of them, but they kind of come together as a group. So like those first four, the thermal mass plus the insulation leads to thermal performance, which means you get reduced HVAC loads, which means for the occupant, comfort and utility savings on your utility bill. The other thing is speed of construction. We can eliminate having multiple trades that are performing different functions because the wall is the insulation, it is the forming, it is the attachment surface, it is the vapor barrier. On some level, we can kind of get away with being the air barrier, the vapor barrier, the insulation, and the structure. So you're seeing a reduction in schedule. We can also build during cold weather because we have an insulated concrete forming system. The system is extremely strong and extremely durable. We also get great results when you're talking to an engineer about the seismic loading and the wind loading. We do a lot of projects that are in high seismic zones, and we've had a lot of amazing results with projects that are in wind zones. You can see that picture down below, a greater impact resistance. That's an amazing story about a project in Mexico Beach, where everything around that building in the Hurricane Michael was literally destroyed, and that building stood there. So we do a lot of storm shelters, and we're getting more and more interest in places that have either wind or fires as well. The simplicity of the system is really probably what's best when you're talking to an architect. It reduces risk. it's a simple assembly. When assemblies are actually getting more complex, ours is quite simple. Sound transmission is an amazing benefit. It's also high performance yet affordable. So now we kind of ran through all of those bullet points, and there's more.
Well, we'll definitely make sure we have.
Next month.
Exactly. Well, we'll be able to cover them in more detail in the future months. But I mean, I think what's interesting, and Paul, you've said this to me. It's like you look at all these and you're like, wow, it's too good to be true. So, and that's where I want, that dialogue. If there is a concern anyone has, that's when you need to reach out to us and let us know, because we've got the data, we've got the testing, we've got the actual testimonials from users.
Yeah, and as I mentioned earlier on the rebar, we're continuing to work on further improving the simplicity. And I think in addition to the fibers I mentioned, there's a few other really cool things that are coming in the next couple of months that just make it that much easier.
Yeah.
So we're always working on simplicity.
Yeah, that's going to be a great addition, Paul. We have a lot of people asking us about, reducing rebar congestion by adding fibers. So really glad that you guys are working on that.
Well, just I guess blind dumb luck that Nudura becomes part of a family that's got the world leader in fiber technology,
Right.
and it's of course just a couple miles right up the road.
Right.
So
where we sit,
that was fortuitous.
Yeah, it definitely was. Well, Eric, I know you've been a great resource for me and so many other people at Tremco when we all came together. But I know you have a great resource in the industry as well that we'd like to introduce at this point and have him join us on Tremco Live.
Yeah, Nick Brown is a building energy consultant in California, and we met at the Net Zero conference out there. And there he is. Hi, Nick.
Hi, everyone.
Hey, Nick.
Hey, Nick.
Thanks for joining us.
Thanks so much for joining us. Net Zero is right up your alley, right? According to all the information that Eric has shared with me. I know you've shared with me. You're an educator. You go out and you get really involved, and I think you are a remodeler and a homeowner of a net zero building as well. So it's definitely near and dear to you. So definitely worthy of coming on and talking to us all about ICF and of course energy.
Right, pleasure to be here. Thank you. And I've been watching the ICF industry for a long time from my vantage point, formerly as a stucco manufacturer. We'd exhibit at the same shows and always admired the product. And now I'm in a position as an energy consultant to where I can specify it and fully understand the benefits and the differences. So happy to talk about that with you today. Great,
thank you. So you've had all this experience in teaching different classes. In your opinion, what are the benefits that you see? What benefits ring true to you in your construction?
Yeah, we'll focus today on the thermal piece. In California, we've got a few unique things that ICF satisfies. One is we've got our very own energy code, and we have a 40-year history of departing from the rest of the country with our own energy code and figuring out how to reduce energy waste, basically, in buildings by requiring those things that are most cost-effective to be built in. And energy modeling is at the heart of the California approach to energy code. So that's one. Two is fires. Just become a fact of life now, to where we've got summer and we've got winter and we've got fire season. And sometimes it includes both of summer and winter. So a lot of the fire rebuild areas are very interested in ICFs because they recognize that this is a system that's going to stand up better to those sort of natural disasters than the traditional stick-built framing approach that's typical here. And along with that comes, no matter where you live, you've got smoke, you've got bad air days, And so, like Eric said earlier, the compartmentalization benefit of ICFs, the ability to separate your indoor environment from the outdoor to weather those storms, so to speak. I've gotten passionate about indoor air quality. And so I'm really interested to talk to you today about not just the thermal benefits, but some of those other ancillary benefits that really make your system compelling.
That's great.
So Nick,
Go ahead.
one of the things that we saw was that when you're doing the energy modeling was just getting the data input correct was a significant piece of that. How do you enter an ICF wall into the model?
Right, and it's one thing when we're modeling a simple stick-built 2x4 R13 wall. We all know how to do that. But when we model a system that maybe we're only seeing once a year in our projects, like ICFs right now, until it really catches hold and gains momentum, yeah, we can get it wrong. So that's what this window is in the second center of the screen. Our energy modeling software provides for precise modeling of an ICF wall, layer by layer by layer. That's the approach in the California software, both residential and commercial. And that's what this is on the screen here. We define the thickness of the continuous insulation on the inside of the wall, as well as the outside of the wall, define the R value of each, and then the thickness of the thermal mass layer in the middle, the concrete. Because really, if you think about that wall, let's think about it in a hot Southern California summer day, where you've got a 30 or 40 degree differential across the wall. Well, that heat first has to penetrate the outer layer of continuous insulation. And it's going to penetrate, but that R, 12, 13 is going to slow it down a lot because there's no framing for it to shortcut through it. Then it's going to have to heat up that whole thermal mass layer. You know, minute by minute, that layer is going to heat up, but it's going to take a long time. You remember going to grade school in the morning and how cold those walls would be because the heater was off all night? Same concept here. And then once that middle layer's really heated up, it's got to transmit through the interior layer. So it really is a great system for resisting the heat gain in a hot Southern California summer. And at night, it's going to have the ability to reacclimate to a nice cool temperature so it can do the cycle all over again, much like the California missions did, only without the insulation to slow down the transfer in addition to having the thermal storage.
I think it's a great way to really demonstrate that effect of the thermal mass, which is what a lot of people miss.
Yeah, Nick, is there, from an industry-wide perspective, can you comment at all about the thermal mass standards, testing? What are your thoughts on how this is kind of viewed from a standards perspective?
Well, we're talking about digging into that a little bit more fully with you and really understanding how the algorithms work. So stay tuned for a real energy nerd session. Marcy, it may not appeal to your whole audience. It may have to be a supplemental episode. But you're right, Paul, to ask that question because these modeling software packages are a black box to some extent. Really hard to see what's going on under the hood. And so we need to make sure as product manufacturers and energy people that it properly reflects reality. And that's what we're proposing to do.
So yeah, one of the things that I really struck me with the project that Nick and I were working on is I came across a project that was modeled, and it was modeled incorrectly. The input was done wrong, and it was just a simple error by the person who put it in, and basically the nomenclature. They said, oh, this is an 8-inch wall. They assumed that the concrete core was only 3 inches. And so everything kind of didn't come together from there. And then I called Nick. I said, hey, Nick, the software that you guys are using, does it calculate the thermal mass into the thermal model? He said, yeah, it does. And so that's when we started to really dig into this and discover how the software is using thermal mass, calculating that in. It's also, isn't it running it over for different climate zones and like over an entire year?
That's right. Hour by hour for an entire year for a typical weather year. And we have 16 of our own climate zones in addition to this US's IECC climate zones. So we have tight definition on, Palm Springs is the most extreme on the hot side, and the Sierras are the most extreme on the colder side, climate zones 15 and 16. So it's going to function very differently in each of those two.
Yeah, and then you'd have to explain this to everybody, but there's a system of points that are used called EDRs, and then when you modeled the wall, it demonstrated that our wall, or an ICF wall, any ICF wall, would contribute greatly towards those EDR points that you need to meet the what's called Title 24.
And Paul, this is another LinkedIn success story because I saw Eric post on his San Luis Obispo house or something about how great his ICFs were. And I had just taught a class for our Energy Code ACE team for residential architects, helping them understand how to work in concert with the California Energy Code to get their projects to comply. So it isn't a battle every time. And one of the examples, which is shown on the screen here, showed the standard wall, which is in the gray column, which in most of California for residential new construction is a 2x6 wood frame wall with R21 in the cavity plus R5 on the exterior side, continuous rigid insulation. And we contrasted that with 3 upgrades in green columns. And the last one we threw in was an ICF wall. And it showed a 3.1 EDR advantage over the prescriptive standard wall. 3 EDR points when the target is about 50 is huge. There are very few things that can move the needle that far. Certainly on the walls, it's as good as you're going to get. And as you can see on this chart, if you compare that 3.1 EDR impact of ICFs to triple pane windows, it's bigger than triple pane windows. It's bigger than everything but a heat recovery ventilator, I think, in this case. So I posted on Eric's post on LinkedIn, hey, I just taught a class, and by the way, did you know the impact that you can get from ICFs? And that's what led to this discussion today.
Yeah, so it was a real breakthrough, Marcy. What we discovered was that the wall needed to be entered correctly, that the impact of the wall was remarkable, and that that we could model all sorts of different configurations of the wall, and that it was taking thermal mass into effect, and it was doing it over an entire year in any climate zone. So we figured, hey, we can configure almost any wall in any climate zone and test it out. Then we wanted to see how it would corroborate with our testing. But the other thing to think about also is airtightness. These walls that we create are extremely airtight, whereas a wood wall really is harder to get airtight. So Nick, maybe you could talk about how that plays into the modeling and what the default is for air leakage.
Yeah, as I said, a pet project of mine right now. It doesn't happen automatically. If you specify an ICF wall in the California modeling software, it's going to assume it has the same leakage as a stick frame wall. And that standard right now is 5 ACH 50. We, however, can override that if we do a blower door test in California and prove that we're better than that 5 ACH 50. Well, in that case, I can put in the model 1 ACH 50, vastly improved leakage, which reduces the air infiltration, right? And thus reduces the burden on our HVAC systems to compensate for that. So when I do that in an ICF home, Eric and I have seen a real nice boost to what is already an excellent thermal advantage. Well, now that you reduce that infiltration, you get another boost. And so that's another training item for us as we learn to specify ICFs in California. Don't leave the infiltration benefits, on the table. Put it in your model. I've heard it's pretty cheap to conduct one of those blower door tests. One guy told me $250, and that can get you enough EDR points where you don't need to upgrade the water heater, for instance. And that's how the California software works. It's a series of trade-offs to where a product like ICFs has a dollar value because it precludes the need for other upgrades. Or, of course, you can build far better than code minimum and save money on your utility bills.
Awesome. Very great. You guys, great information. I know more to come on that. As Nick mentioned, we are going to be doing some things with him, and we'll do some further broadcasts. It's really great to see those bullets of benefits kind of come to life, one at a time, a couple at a time, right, through these broadcasts. So we really do appreciate both of you coming on and sharing your knowledge and your experience with us. Any final thoughts from you guys? We'll start with Nick before we close for today.
Well, I think the big question mark for me always on ICFs is cost. And my only suggestion would be help us understand those cost comparisons to stick frame so we can really specify it more, because it's a clear winner on thermal performance, compartmentalization, comfort. And I'd just love to find more places to specify it.
That's great. Great.
Yeah, I think, Marcy, we should do some work on, we'll call it speed of construction or ease of construction, right? So efficiency of construction, and do some side-by-side trials on that. I think that's going to be great input for Nick.
Yeah, absolutely.
Love that.
And Eric, what about you? Some final thoughts for us today?
Well, I would just add to that saying that without properly thermally modeling the building, you don't get the benefit of ICF. You have to do the proper thermal modeling, and then you can downsize your HVAC system. So those are first costs. And so comparing apples to apples can be challenging, but I think what you're going to find is if you really look at what an ICF wall can do for both below grade, above grade, whether it's residential or commercial, that it's not only going to pencil out, it's going to be a really good decision for your project. So I really encourage people to learn more, to reach out to us. And then in California, Nick and I have the tiger by the tail when it comes to how to model this properly.
Yeah, I think, Marcy, Eric brought up a great point. We've heard from other builders, it's really hard for them to get their head around how much they can downsize the HVAC equipment. And a common initial error is oversizing just because. So that's going to be a great topic for, again, another month.
Exactly, another future broadcast.
And we can see that in our software too. Switch the walls to ICFs and we see that peak heating and cooling load drop.
it gives them that validation to be able to do that. Well, Nick and Eric, thank you so much for joining us today. We really appreciate your time today, and we'll see you again soon, I'm sure, on a future broadcast. Thanks so much.
Thanks, Eric. Thanks, Nick.
Pleasure. Thanks for having us.
Marcy, did you tell Nick about our thermal chamber?
I did tell him.
Okay, good.
We've had some conversations for sure. So I know, I think the Nudura guys for sure, all of them as a whole are very anxious and, wanting to see how that can contribute in terms of bringing that data to life, right? So as we bring those bullets to life and bringing those data points to life, we're really excited about that.
Yeah, and also to compare and contrast with the other systems out there.
Absolutely. A couple resources here we just want to make sure you guys are aware of is there's a couple documents that we will share with you as well, but this, the Build Meets World has a lot of different topics in there, and there are several associated directly with the insulated concrete forms. And then there's a great comparison document called Why Would You? It's just talking about wood construction directly compared with insulated concrete forms. So some really great resources you can find. Build Meets World, you can Google that, and you can also Google Nudura, Why Would You? And you'll find another document. And once again, we really appreciated Nick and Eric coming on today. Great subject matter experts, but we know you might have some existing questions or challenges or, just inquiries about insulated concrete forms in general. So there's my email address. Please reach out to me. We really want to hear your feedback. And once again, if at any point you want to join the conversation and join Paul and I, we would love to hear from you. So please let me know that. And otherwise, that will conclude today's broadcast.
Great session, Marcy. We'll see everybody next week. Be safe.
Thanks, everybody. Bye.